All right, everybody, here we go. Here's some notes here on proving the equation is an identity. Now, a couple of rules before we get started. First rule, pick one side and work on one side. It sometimes is easier if you work on both sides. However, in certain classes, you are required to work on one and only one side. That being said, usually it's easier to turn a big equation into a little piece rather than take a little piece and make it bigger. Now, that's not 100% true all the time, but usually that is the case. So, let's just get started. What we're going to do here is we need to manipulate the left side to make it look exactly like the right side. Now, you can see that the right side is sine and cosine only. So one of the first things you might want to do here is rewrite this as sine x over cosine x plus sine x times cosine x over sine x. And of course you have your cosine x in front, and that's equal to sine x plus cosine squared x. So what I did there is simply get rid of the tangent and cotangent, so we are in terms of sine and cosine because that's what the right side looks like. And now what you can do is you can simplify this a little bit. We can just, bang, get rid of those signs right now. So our next step is going to look like this. Cosine x times sine x over cosine x plus cosine x. And that's still equal to sine x plus cosine squared x. Yes, before you even ask, you must write the right side or whatever side is staying the same the whole way down. Next, you see a distributing step. So cosine x times sine x over cosine x is just going to cancel out those cosines, and you're just going to have sine x. And cosine x times cosine x is going to give you cosine squared x, and hooray, you're done. So it's true. It worked out just fine. Now that's an example of a really easy one. Don't be shocked if you work on a Pythagorean identity type problem where you have to, use a couple of different Pythagorean identities and have it be like 8, 9, 10 steps long. You might have some factoring to do. There's going to be all sorts of hoops to jump through. These are pretty much just some easy ones to start you out. Number 6, you can see that you have an addition of fractions on the left-hand side. That's way more complicated than just 2 cosecant squared x, so you want to start with the left side again. Now, it's not always the left side you want to start with. Just pick a side that looks easier to work with. So for this one, you need to have a common denominator before you're going to do any adding or subtracting. So you can see right from here that this side's going to need a 1 plus cosine x, and this side's going to need a 1 minus cosine x, because your denominator is going to be both of those multiplied together. So first step, you're going to have 1 plus cosine x over both of those plus 1 minus cosine x. Now, it is okay for you to just go straight to this all over 1 minus cosine x, 1 plus cosine x. Skipping steps is not usually allowed, but I can understand that you can just take this and go straight from here to here. That's not a big deal. All right, so now what are you going to do from here? Well, obviously, you should probably combine some like terms. So the top, we have 1 and 1, which is going to make 2. Cosine x and a negative cosine x are going to disappear, and that's all going to be over 1 minus cosine x, 1 plus cosine x. That's still equal to 2 cosecant squared x. So now the question is, what are you going to do? What other types of hoops do you think you can jump through now? Well, how about you FOIL those guys on the bottom? If you FOIL these guys on the bottom, you're going to have 2 over 1 times 1 is obviously 1. 1 times cosine x is cosine x. Negative cosine x times 1 is a negative cosine x. And you have negative cosine times cosine, which is going to give you a negative cosine squared x. And that's all equal to your 2 cosecant squared x. These guys cancel right there in the middle. So now you're at 2 over 1 minus cosine squared x. And that's equal to 2 cosecant squared x. And there's only one more step, pretty much. You can kind of see it already. What you want to do here, this is a Pythagorean identity. Remember, sine squared x plus cosine squared x is equal to 1. So if you were to subtract that from both sides, you would have minus cosine squared x would just be equal to sine squared x. And that's where your step comes in. So 1 minus cosine squared x is actually equal to sine squared x. And now, final step is just bring sine squared on the bottom to the top, which means that becomes cosecant. So your final answer is 2 cosecant squared x is equal to 2 cosecant squared x. There you have it. So again, like I said, sometimes these are a little difficult. Sometimes they're pretty easy. Really, it depends on the problem. And again, as I mentioned before, these can be done different ways. The way you do this can be totally different than the way the person in front of you does it, can be totally different than my answer key. When I grade all of these quizzes and tests, I have to go through every step to make sure your mathematical steps are correct. So there are different ways to do these. Just keep that in mind. The way I do it now is not the way you are required to do it. This one, first step, factor. You have the difference of 2 squares here. So this is just like x squared minus 4. You would have x plus 2 and x minus 2. Or this is going to be cosine squared x plus sine squared x and cosine squared x minus sine squared x. And that's equal to cosine squared x minus sine squared x. And hooray, look at this, Pythagorean identity. 1 times cosine squared x minus sine squared x is equal to cosine squared x minus sine squared x, and yes, you're done. This is just a multiplier of 1. Make sure you point it out to me that you know that's 1 by putting like a little 1 above that, and you're done. That's just like a 2-step problem. And this last one, this guy right here, you can see the right side is in terms of secant and cosecant. The left side is just tangent and cotangent. So usually it's easier to take fractions and add them together and turn them into one term than to try to figure out a way to split these up into fractions. So again, we're going to work on the left side for this one. We can easily see, we could just write these in terms of sine and cosines. So this is sine x over cosine x plus cosine x over sine x. That's equal to secant x times cosecant x. Next thing you want to do is get common denominator again. So we know the common denominator is going to be sine x cosine x. So this side needs a sine x. This side needs a cosine x. So on top you're going to have sine squared x plus cosine squared x. And as you can see, you're pretty much already done again. Make sure you set that equal to secant x times cosecant x. The top, again, another Pythagorean identity. You better be very, very familiar with all of these and all of their forms and being able to manipulate them, because this just turns into 1 over sine x cosine x is equal to secant x cosecant x. And all you need now is your reciprocal. So yes, you can just kind of flip-flop these because it is multiplication. So cosine goes up top as secant, and sine goes on top as cosecant. And there you have it. And that's it for this video anyway. These are just some easy examples, pretty much just to make you familiar with what proving a trig identity is. All of the problems that were at the beginning of this note sheet is something that we've already talked about in video number 1. So there you have it. This is Longo and I'm out. See you, bye.